Hi, Assalamualaikum. For this session, we are going to discuss tutorial 12, chapter 24, problem number 12. Monochromatic light of wavelength lambda is incident on a pair of slits separated by 2.4 times 10 to the power of negative 4 meter and forms an interference pattern on a screen placed 1.8 meter away from the slits. The first order bright fringe is 4.52 mm from the center of the central maximum. So this is the solution. So you need to draw the diagram, or in my case I sketch the diagram. Okay, this is the screen where you can see the patterns of the fringes. This is the slit. Okay, slit 1 and slit 2. This is the separation distance of the slit, which is 2.40 times 10 to the power of negative 4 meters. This is the distance between the slits and the screen, which is 1.8 meters. This is the path from the center, from the middle of the slits to the screen for the first bright fringe. Y1 is the position of the first bright fringe. Okay, this is the series of fringes on the screen. This is the dark fringe, the first dark fringe, the second dark fringe. Okay. Okay, so this is the solution for question A, to draw the diagram. Okay, so for B, you need to find the tan theta, the tangent for the first angle, or the angle for M1, the angle for the first bright fringe. Tan theta 1 equals to Y1 divided by L equals to 4.52 times 10 to the power of negative 3 divided by 1.8 equals to 2.51 times 10 to the power of negative 3. Okay, so that's the solution. Okay, for C, the theta 1 equals to inverse tangent 2.51 times 10 to the power of negative 3 equals to 0.144. So the angle is very small. So if the angle is very small, then inverse tan will be approximately sine 10. It's almost equal. So you can check sine theta 1 equals to sine 1.44 degrees equals to 2.51 times 10 to the power of negative 3. Okay, this value is similar to the tan theta 1 value. And then for C, this is the path difference, d sine theta. D is the separation distance of the slit. Sine theta equals to m lambda for the condition of m equals to 0, plus minus 1, plus minus 2, plus minus 3. Okay, that's the condition for the bright fringe. This is where the central bright fringe, this is the first bright fringe. So for this question, ask for the first bright fringe, so you need to replace m with 1. So the lambda, the wavelength of the light, equals to d sine theta 1 actually, okay, divided by 1, equals to 2.40 times 10 to the power of -4 sine theta sine 0.144 divided by 1. So the answer is 6.03 times 10 to the power of negative -7. Okay, you just remove this dot, okay, because it's actually 603 nanometer, not 6.03 nanometer. It's 603 nanometer. Okay, so it's 603 nanometer. So for y1 just now from the question is 4.52 millimeter. So from here, okay, so for question E, m equals to 5. You need to find the angle for the fifth bright fringe. Begin with this equation: d sine theta 5 equals to m lambda, where m equals to 5. So you need to replace the m with 5 to find the angle. So the angle, the fifth angle, is equals to inverse sine 5 lambda divided by d. So inverse sine 5 lambda, 5.663 actually. Okay, 5 times 6.03 times 10 to the power of -7 divided by 2.40 times 10 to the power of -4. So it becomes 0.720 degrees. That's the angle, that's the fifth angle. The angle for fifth bright fringe. So for question F, y, you need to find the position of the fifth bright fringe, L10 theta 5, 180, 10, 0.720, then it becomes 2.26 times 10 to the power of -2 meters, or 2.26 cm. Okay, so this is y5. Okay, if you have a long paper, then you can draw the fringe there. Okay, that's all. I hope you understand. Thank you for watching.